Okay, so now we have to get into the details of how to use this ECU simulator. So before we get into the detail, there are many things as an IoT person you should know. Okay, I mentioned to you that there are these 5 knobs which essentially talk about 5 different sensor outputs which are available from an typically from an ECU. One of the important things that we see as an output here is the mass airflow. We will come to that in a very short while. Then there is oxygen, then there is engine RPM, then there is speed, temperature here it is coolant temperature. These are the sensors that are available. Yes, also we looked at if you look at the engine manifold and if you look at the throttle body, which is just connected to the engine manifold to provide the required ratio of air to fuel mixing. There are several things. This is essentially referring to that ECU which is talking about the engine manifold and the corresponding throttle body, which is essentially forming the complete system as far as the engine fuel injection is concerned. So this is, I would say, more for fuel injection, combination of the engine manifold as well as the throttle body. In IoT, the one thing you have to be very clear that if you want to work in a particular domain area, if it is on air quality or on automotive or on energy systems or any one of the current topics, you must get into some detailing from sensors perspective, from embedded programming perspective, and also from a high level understanding perspective, without which I do not think you will be able to make any good progress in your development of IoT systems or even in the area related to where IoT can be applied. So keeping this in mind, let us go and do a little more study on all these aspects. You see there is a connector here, this is the connector of interest. This connector I mentioned to you is called the OBD2 connector, onboard diagnostics version 2. 1 is over, it is all gone, forget it. So 2 is what is now most prevalent. If you own a car, okay, it will be a good exercise to find out where is your OBD2 connector. In my car it is just below the steering, somewhere on the right side there is a lever to open the engine compartment. Somewhere in that region, if you look down peep a little deeper, you will see a connector, and that connector is essentially the OBD2 connector, to which you can connect something, some small scan tool equipment you can connect and start observing the diagnostic information about the car. So what does the OBD2 in a high level sense do? It is a term referring to vehicle's self diagnostic and reporting capability, not only trying to find out if there is a fault within by doing some very intelligent tests, but it is also supposed to have a capability to report a fault condition. Okay. So this diagnostic information is available via this OBD2 port. Now if you read literature on this OBD2, you will find very confusing documents, lot of information is available out there. Just to give you a very quick overview, I put down 3 protocols of interest. Okay. One is related to connector and some hardware specification related. The second thing is protocol related, and the other is with respect to the parameter IDs, or also called the PIDs as it is called. If you look at the connector related information, there is a specification from SAE, Society of Automotive Engineers, J1962 specification. You will have type A and type B in them, and you can't essentially, it will be the same D type, same form factor. You do not want A to mate into B and so on, and therefore the receptacle is slightly, while the receptacle housing looks the same, this groove that you see in the middle, you see this groove here, this is continuous, okay, it is continuous groove. So you can just move your pencil or whatever just directly, and then you see that there are no cuts, whereas there will be an interruption somewhere in the middle if it is type B. So, you will see that you cannot take A and put it into B and vice versa. So, that is essentially the idea. The second thing is what is the protocol running, because IoT folks will be interested in the protocol part, because that is where all the intelligence and algorithms that IoT people would like to sort of program the system into. That part of the protocol is essentially supported by ISO 15765. I mentioned to you so many other protocols, but this appears to be the most popular one. CAN, which is also something that Bosch came up with this specification. You have low speed CAN and high speed CAN, and so CAN is a very important protocol. Now, the parameter IDs themselves have a specification, and that is the SAE J 1979, and these define the parameter OBD2 PIDs. My suggestion is, if you want to know more about PIDs, it is best to look up Wikipedia, and you will find a wealth of information on OBD2. So, I do not want to repeat what you can easily find, but we should take an example to connect everything together. Okay. So, for that purpose what I will do is I will take whatever I am most comfortable on this engine ECU. Okay. It is obvious, right, you want to demonstrate something, and it is good to take one sensor and go a little more into detail and look at the parameter IDs and so on of that particular sensor. For that purpose I have chosen mass airflow, MAF. Okay. MAF is an important sensor. Now, what is this MAF sensor, how does it work, what are the problems, all that let us get into details. This is the engine manifold, this is the engine manifold, okay, and this is the air filter. Now, MAF essentially is in the middle, okay, and it is a very crucial one for any electronic fuel injection system. Okay. This is the most important. So, what happens here is the air is coming in here. So, there is air inlet. The air filter essentially removes all the particulate matter, right. It removes particulate matter, all materials, all particles which can actually destroy an engine head. If these particles go inside, they can actually destroy the engine. So, you have to remove all those unwanted particles which are suspended in the air particles, and therefore, you put a air filter. By the way, if air filter blocks, you will have another set of problems. We will not get into that, we will just concentrate on the MAF part. It is a mass airflow measurement device, and it is an interesting sensor, by the way. It is a very interesting sensor. The way it works is very simple. How do you measure mass airflow? How do you measure airflow at all in the first place? Imagine that there is a heater, okay. There is a heater, I will call this a heater, okay, and I will apply some voltage to it, and it starts heating, okay. To this I somewhere close by I will put a temperature sensor, I will put a temperature sensor, okay. Now, it is all inside this, by the way. So, this heater is essentially maintained at some temperature, okay. You are measuring the temperature. Now, if air is, there is a flow, either it is typically I think a laminar flow, flow across the heater, if the flow rate is low, right, you do not need too much current to keep the heater at that given temperature. So, the temperature sensor is measuring the temperature of the heater, at what temperature the current is passing, and therefore, what is the heater's temperature is measured. But if the airflow increases much higher, okay, if you have a much higher airflow, you need to pass higher currents, right. You need to pass higher current in order to maintain the same temperature. So, this current that is flowing is directly proportional to the airflow. I have given you a very high level view. So, now you plot what is the current and what is the current versus airflow. Okay. It is a nice linear relationship, fantastic, nothing like it, it is a good linear sensor. I think airflow here it is measured in grams per second, mass airflow. So, you say in terms of grams, and this is the current in either milliamperes or amperes. If you pass this much current, this is actually the airflow, you can directly calibrate. So, this is what is sitting inside this, it is measuring through what is known as a hot wire. This is also called the hot wire measurement device. So, essentially mass airflow sensor measures the amount of air which is entering the engine, which is also called the airflow. Now, so this simple electrically heated wire, which is nothing but the hot wire, is the one that actually measures the airflow. So, now if this condition is low current is typically when the engine is idling. When the engine is idling, you do not need too much of airflow around it. So, it takes very small amount of current, you can see this current is also very small. But when you press the accelerator, when you press on the accelerator, your leg is pressed on the accelerator. Remember, I had connected it to a potentiometer, right. So, this is the accelerator pedal. If you press on the accelerator pedal with your leg, okay, the throttle will open and that will allow more airflow through the hot wire. It will allow more flow through the hot wire, and that will be proportional to that airflow you want to measure. And in order to keep it hot at a given temperature, you need to pass an electric current which is more, and that information of how much current you are passing is given to the engine ECU. Take this I and give it to the engine ECU. So, directly you will get MAF, a value for MAF is available to the engine ECU. Now, what that this engine ECU does, there is a piece of code, right, everything is software inside, there is a piece of code running inside the ECU, the algorithm that is there in the ECU. I will simply denote it by flower brackets just to show that there is some code running inside, and this MAF is taken and it shifts the transmission. Does if it is an automatic transmission system based on the MAF value, if it is let us say gearless vehicles, moment you press on the pedal, you will have to increase the speed. So, it shifts to the automatic transmission signal is given, and then the speed picks up. Okay. So, this is as simple as this, but while what I have written here appears very simple, what can go wrong, what is the issue with this, is there any problem at all if it is such a nice lovely system to work and all that, you will see that that is where IoT will play a very important role. Okay. Let us now go to what can happen with this MAF sensor and how IoT can play an important role. Okay. MAF problems. First thing is, let me give you an overview. There has been no world leader vendor in this area which have not had problems with MAF. BMW BMW has had problems with MAF sensor, GM have problems with it, Volkswagen, okay, then Mazda, then Toyota, then Nissan. All these companies, big companies, both Japanese as well as German companies, manufacturers, big massive giants who have been manufacturing for several decades, have had problems with the MAF sensor. So, therefore, it is a very critical sensor. First thing is it can get contaminated. It is easy to see that it can get contaminated, it can get damaged. It is clear, right? If you go back and look at this picture, if your air filter is horribly bad, if you do not change your air filter, your MAF can go bad. This hot wire element can get contaminated. So, it is because it is in a very critical position, which is taking something from the environment. Okay. See, do not forget the bad air which we are breathing in cities like Delhi, where the air quality index is I do not know 2.5 times the safe levels, while on the one hand the worst suffering is happening to humans, right. It is not that cars are anywhere safe also, they are also having this problem, because that whole particulate matter will come and sit on this air inlet, on this filter will have to work twice, it gets contaminated faster, and if it gets saturated then the MAF will go bad. So, if you buy an expensive 1 crore car, okay, a 1 crore rupee car, and if its air filter is contaminated quickly, MAF sensor goes bad. This can also happen. So, polluted air can be a cause of concern, while automotive manufacturers have to be blamed for not adhering to pollution norms, and they are the cause for several of these problems which are happening in larger cities like Delhi. It is not that the vehicles that they manufacture are also redeemed of this problem, it is not that, they are also suffering from the same kind of issues that humans are. So, the problem is horrible when humans are involved, and because we end up with a lot of breathing problems, and high levels of contamination can create problems to our lung and all that. It is a very bad thing to happen, but you see how the vicious circle has developed: vehicle polluting, vehicle pollution creating problems to humans and also creating problems to vehicles and so on. I feel that IoT should do something in this kind of space. This is the most important thing you have to bear in mind. What can I do? What can we do if we know and we have access to cheap sensors and we know how to write code? Even in a very expensive 1 crore rupee car or a 2 crore rupee car, we still have access to several sections like what we discussed here. You should be able to do something. So, that is the goal. So, now let us go back and look at the, so it can get contaminated, it can get damaged very quickly, and once this fails, you can't start the engine anymore. The airflow sensor could cause the engine to crank but not to start. So, engine crank can happen, engine may not start also, may not start, that is the problem. So, it is a problem. Alright. So, when the airflow sensor, this one sensor signal varies over and above a expected range, the mass airflow sensor can record a fault. You can record a fault straight away, and OBD2 becomes extremely useful to record this fault. What actually happens is the following: if you own a car and you put in your car key, the first thing you will see on the left side is a set of lights that glow, right. One of them that you can easily spot, which looks a little peculiar apart from fuel, which shows a small can and a drop there, and then the handbrake signal and battery signal and all that, you will find one mill indicator. It is called mill, just remember it as mill. This is called malfunction indicator light, malfunction indicator light. Some people call it by check indicator or something like that, but I think the most popular appears to be indicator light. It has a symbol which you cannot forget. Okay, you please look up that symbol for mill indicator light and you will see it directly on the dashboard. Moment you start the car, that it is expected that the whole thing, the dashboard that you see on top completely vanishes except the handbrake. Moment you release the handbrake, even that light goes away. Then you know your panel is clear and now it is good to start and it is good to go. All that means that it is doing some self tests, it is doing self diagnostic, and if that light does not go, the mill light does not go, clearly it will record it in the ECU and you can retrieve it. It will record it in terms of some OBD2 data. Okay. It is called, it will indicate a PID, this is called the parameter ID, it will indicate the PID and it will indicate, and moment you look up connect a scan device to it, you should be able to read the parameter ID and find out what that fault was. Okay. If you take a car or if you take a vehicle, we have the engine, we have the chassis and we have the body. The engine part was also called by powertrain, right, powertrain. So, the actual power coming from the engine, and therefore it is called the power part and then the chassis part and the body part. Therefore, since there is a P here, you will see that the OBD2 code corresponding anything with respect to engine will start with P. Typically you will see P0100 which is MAF, it can be MAF malfunction, it will directly indicate. This is a standard parameter ID. So, it is something that is defined in that standard I mentioned to you. And which is that standard? You may want to go back and recall the standard. The standard for PID is J1979. As per J1979, OBD2 parameter IDs are already defined. Vendors can add their own, they can have their own and they can define it and all that, but standard parameters ID have to is something that vendors have to implement essentially. Similarly, you have P0101 which can correspond to a mass airflow circuit range, okay, it is beyond range, and P0102 is mass airflow circuit low, okay. So, you can have circuit high which is 103, then you can have 104, there is a circuit intermittent and so on. So, you will have what are known as DTCs, diagnostic trouble codes. It will essentially indicate the diagnostic trouble codes. There are essentially 10 diagnostic services, okay, in this. Actually, you can look this up in Wikipedia, but for completion I will just write it. 01 is show current data, okay, and 02 is indicating show freeze frame data. Very useful for IoT guys. Okay. I will tell you why. 0 1 provides current information, okay, current information, whereas 0 2 provides a snapshot of the same data taken at the point when last diagnostic trouble code was set, last DTC was set. So, this has some sort of time information. Okay. This is useful too, that if you take it at a snapshot, essentially you are freezing the time at which this malfunction actually occurred. So, you have some time information. Now, look at it this way, if you have the time information and if your vehicle had a GPS associated with it and you know where and what point in time this MAF sensor gave a alert or gave a malfunction, you essentially know something more about the fault. For example, supposing there is a road and then there is a hill and then there is a flattening and then there is a much steeper hill, and you find that the 02 code was recorded here, you clearly know you have additional information that the MAF sensor failed here when the car was climbing. Now, whether you can use that information to further improve is another story, but the fact that you get a lot of data moment you know at what time this MAF malfunction happened will be useful. P01 will simply show some current data that there is a fault, it will just indicate that and leave it, but this gives you that freeze information which is adding a lot more value to this whole system. So, one can essentially debug better by using these DTC diagnostic trouble codes and OBD2 data, and then you can essentially repair your systems or quickly identify the fault in your systems. So, often you will see that the mass airflow sensor readings you measure at different RPMs. Okay. You measure MAF at 1000 RPM, okay. Then you measure the MAF at 2000, so on 3000. If you find that if it is contaminated, because we started with that, right, if it is contaminated you will find that it is a bad airflow, it will show lower airflow readings, okay, then a good one, then a known good one. Okay. So, if it is contaminated you will find that the airflow is lower, and in some rare cases it can also show some high readings, very high readings. It is just malfunctioning, right, it is contaminated, it is malfunctioning. So, you have no way of saying what is the safe range. Okay, and you have to note that when you talk about MAF you can't generalize a given number, it depends on the engine type, it depends on the manufacturer, so many related parameters. It will just give you a number and tell you that this is what the issue is, it will tell you about the issue. Now, what should be the table which corresponds to airflow and the current consumption and all that, that will have to be based on the type of MAF sensor that is being used for that given engine. So, that you have to note in mind, but nevertheless it gives you an idea that you can do a troubleshooting with this. So, I will just summarize all this. The airflow will essentially depend on what? It will depend on the engine volume, which means from different engines you will have different values. So, this is an important point you have to make a note. So, also you have to note that this low airflow, so when you say low airflow, okay, what does it mean? Does it mean that there is a bad sensor? Not necessarily, it could be this guy could be clogged, right. if you perhaps replace the air filter, the airflow may come back, and therefore it is useful. So, mechanic actually will be able to have the trick of saying whether the MAF has gone bad or whether it is really the air filter that is clogged. So, that is a lot of practice, but if you are able to capture that wisdom into algorithms in an effective manner, then you have actually used IoT sensors and embedded programming to solve a very important problem in vehicles. See, before we go on to show you a demo of this, I want to tell you where IoT will actually come in here. There is a lot more things that you can do in terms of algorithmic work. We should take one or two use cases of an algorithm and try and implement that algorithm in it. So, let us spend little time on understanding a simple way to sort of track the sensors and how we can model something about these sensors in an automotive world.